Okay, we're going to look back at the physics primer question number 7, part F. I had a revelation this morning. I realized that there is a different way to solve it, the way that they actually wanted you to solve it. I had in my previous video solved it using information that we're going to learn later in the course, kind of cheaty. But let's solve it the way that we had solved the previous problem. So these are the two equations they had given us. F cosine theta minus the coefficient of static friction times n equals 0. And then they also gave us this one, F sine theta plus n minus mg equals 0. And they would like us to solve for f, but we cannot use n. We can only solve for f in terms of mg theta and the coefficient of static friction, the mu sub s. This is something you will learn about later as well. So if you have no idea what that symbol means, don't worry, you'll learn about it later. But let's go ahead and solve for f doing what they wanted. So the first thing I'm going to do, because I know I cannot use n, is I'm going to isolate n. So let's see, what equation are I going to pick? I'm going to use this second equation here. I'm going to isolate n. So if I do that, so in this second equation here, if I leave the n where it is, I can add the mg over to here, and I can oops, I did not subtract. I meant to. I can subtract the sine theta, f sine theta. There we go. To move them to the other side. So now I have something I can use to replace n. So let's go back to that first equation. I just used the second one. I can't use it again right now. So in that first equation, I'll replace every instance of n with this. So here's what I got. So let's go ahead and do some simplifying. Remember, the ultimate goal here for this problem is to solve for f. So I'm going to try and isolate f. I'm going to distribute this mu sub s, the coefficient of static friction, and it's going to look something like this. Negative times negative is positive. All right, and I'm trying to get f by itself. So this term in the middle here is the only one that has no f. So I'm going to go ahead and I'm going to add this to the other side to get rid of it. I'm trying to group the f's. And if I add it, it's going to get positive over there. And I'm going to go ahead, I can factor out the f from these two terms, cosine theta, sine. And I'm going to run out of room on my whiteboard. Wait, no, I'm not. I'm good. Okay. And then I'm going to go ahead and divide both sides of the equation by this, with the parentheses that are in here, because that's going to isolate f for me. So the mu sub s, the coefficient of static friction, times mass times gravity, that whole shebang has to be divided by the cosine of theta plus mu sub s sine theta. And there we go. This is another way that we can solve for f, assuming that you didn't have an alternative way to write n like I did in my previous video. And we still get the correct answer by doing it this way. This is actually the way they wanted you to do it. I just forgot. That's not true. I remembered something I should have forgotten. But either way, you end up with this for f, and you can go from there to solve the second part, or part G, where we can then plug in the values they've given us for the coefficient of static friction, the mass, gravity, and theta to figure out that the force necessary would be 29, and that's covered in the previous video.